So partial pressures of gases work the same way that you can think about any kind of mixture. So just like if I'm talking about a mixture of gases, I could be talking about a mixture of fruit. So let's say I had a fruit basket of apples, bananas, oranges, and pears. If I said that I had 200 pieces of fruit and I told you that 20% of them were bananas, could you figure out how many bananas that I had? Right? You would just take your 20%, we know we'd have to put it as a decimal, and then we multiply it by 200, and then we would figure out how many total bananas I had in my basket, which would be about 41.8. So I know I can't have 0.8 of a banana, but all we're doing here, all we're saying is that just like you have a mixture in a fruit basket, we have a mixture of gases in the air. So all these questions are just kind of talking about how if I have a mixture, can I figure out part of the mixture? That's where the partial pressure comes from. So for example, for number 1, it's asking me, what is the partial pressure of nitrogen when the total is 0.987? So I know that nitrogen is 78.1%, and I want to know how much of that of my total. So I know that if I want to multiply these two together, I have to put my percent in a decimal form. So if I multiply them together, then I get, just typing in my calculator, 0.771. So that's saying that out of my total, 0.771 is nitrogen. Now I could go through and I could do all of these the same way, right? Multiply them by the total and get how much each little part really is. And I know that all together, all of these totals are going to add up to my total here, 0.987. Okay, so all I'm talking about is just a mixture of gases. Number 2, number 3, number 4, all of these are just kind of reaching back to what we talked about in the first unit, whereas what happens when we increase the temperature inside a container. So I know that if I increase the temperature, right, my particles are going to move faster. They're going to take up more space, right? And then if I think about how does that affect the pressure, remember the pressure is just how those particles are impacting the side of my container. So now all these particles that are moving faster are going to be colliding with my container more often. So my pressure is going to increase, right? Because my particles are moving faster. Number 3 is just asking, did my actual percentage of oxygen increase? So did I change the amount of gas I had? Okay, that's what that question is asking. Make sure you explain. And then number 4 is now asking, would the pressure of oxygen increase? So if my total pressure increases, what happened to just oxygen? Okay, and again, just think about those particles of oxygen. What happens when I increase the temperature? What's going to happen to all those oxygen molecules? What are they going to do? Okay, make sure you explain. Number 5 is a calculation. So it says that we have a mixture of carbon dioxide and argon. It tells me that my partial pressure of carbon dioxide is 0.080 and the partial pressure of argon is 0.24. So if I want to know the total pressure, I'm just going to add these up. And then that is my total pressure inside my container, okay, or whatever mixture we're talking about. Okay, and then number B, it wants to know how much, what fraction or how much, what percent, however you want to think about it, in the mixture is argon. So if I know that argon has a pressure of 0.24, what percent of that, or what part of that of my total. So this would be just like, let's say you had a test and there were 20 questions and you got 10 questions right. How did you figure out the percent that you got correct on the test? You took your questions you got right and you divided them by the total. So you said, well, I got 10 questions right. There were 20 questions on the test. Well, that's a 50%, right? So that's the same thing that we're doing here. We're taking our pressure of argon, dividing it by the total, and that is going to give us 0.75. So 0.75, you can leave it like that. We know that that's the same thing as 75%. That's the same thing as 3/4. So all the question is really asking is how much of our total mixture is argon, okay? And we can use that because we can use the pressures to figure that out. Number 6 is just kind of, again, relating pressure. What does it mean? So what do you think it means when we say something is pressurized? And then why do you think it's important to do that? Okay, that's just a little question, not a calculation, just based on what you think. What would you say? And then number 7, you're just drawing a particle diagram. So we know it has 10 particles. And we know that oxygen, argon, and carbon dioxide. So we're going back up here to your little percentages up here, okay? And then you're just gonna kind of draw a picture based on that. So if you have 10 particles, okay, how many total do you think would be nitrogen? How many total would be oxygen? How many would be argon? And then explain your reasoning. You do not have to draw it unless you want to, and then just kind of explain how you got there. This part I would like for you to do on your own, so hopefully you've done a little bit of calculations with me, and then this is where I would like for you to try these questions by yourself, and then you have these few little particle drawings here as well, okay? This part of the activity is where you're going to go through, watch a couple of quick little videos, and then answer these last couple of questions, and then you will submit.